From the last video, you will recall that we assembled the unit cylinders we made into a 4 cylinders in line engine. Remember that we merely did a pattern replication. In Fusion 360, we could have done a 20-cylinder engine if we wanted by simply replicating those engines in line. What if we wanted a V-type engine? How do we go about that? In this video, we will take a look at a V engine that was made with the same kind of arrangement that we had last time. Go back to the beginning of this particular file and just do a manual walkthrough. This is familiar creation of the connecting rod, and then we create the piston, and then reduce the piston to the level we want. After doing that, then the next set of operations will create the next set of operation will create for us the crank, and then the pin is slightly enlarged now compared to what we had before. Now we have the rotating portion of the crank, and then at that edge we make these two ends. We use the method we have already described to create the position for the pins to hold the two portions of the connecting rod together, making the holes on the connecting rod as already been described. Now we have a cutting plane, cutting this into two, and then making a component of the second portion of the cut connecting rod there, and then push this one to one side, then push the piston to go meet it there. So the feature was created by selecting the components to be replicated. So two were selected. The direction, obviously the x-axis direction, the number, the quantity to be created is 2, is moving in one direction. And then there's no difference in this case between the choosing of extent and spacing, because we are only creating 2. And on the other axis we choose only 1, and then select OK, and that is done. So that's how this was done. It's a bit simple now. By pattern replication, this second connecting rod with the piston. The next thing for us to do now is to separate the two systems into an angle 90 degrees while moving the crankshaft into an angle 45 degrees to both of them. And that can be done by taking 2 steps. The first step is to, first of all, make sure that all the necessary connections are made. First, we make sure that the two parts of the connecting rod are connected to each other. There is a rotational connection between the connecting rod and the pin on the crankshaft. Then the rotational connection between this pin and the connecting rod on this side. With all that in place, we are now able to rotate the crank through an angle 45 degrees. If we rotate the crank through an angle 45 degrees, we get this kind of position, and we can look at it from several angles. So everything is in place like this. We take a direct right look at it so that we can see how that looks in 2 dimensions. Now, having done that, the next thing to do is to move this system a further 45 degrees away down here. And to make sure the crank doesn't move, we might begin by taking the crank and grounding it. If we ground the crank, we'll be assured that it will not move in that motion. So we are going to do that. So we ground that crank, And then once we have pinned down the crank, we can now request that there is an extra motion in the crank is grounded here. So we want now to make an extra motion of an extra displacement of 45 degrees. So we have this two pistons that are now oriented to each other at 45 degrees. At this point, we can go back now and unground that crank so that we can now complete the fixing of the necessary joints in the other connecting rod and piston before we begin the replication process. In the next few motions, we are just applying all the necessary joints, just like we did before. We will joining the piston to its pin, the pin to the connecting rod to the crank shaft, and then the upper part of the connecting rod to the lower part of the connecting rod, and all the connections that we have, just like we made them previously. Look at the profile that was used to create that. So we take a profile. This profile was taken on top of the piston. So on top of the piston, we just do a 2-point rectangle to the extent that we need, and then we are just going to extrude that both ways as far as we like. So and that's how that is created. Very pretty straightforward and simple. Now the opacity control of that opacity control is easily used. So if we can, the opacity control comes from we call this cylinder block, we call it engine right, and if you right click on it, you see there is something called opacity control in the drop down menu. Just by choosing anything other than 100%, it's going to give a measure of transparency. If you choose 0, then it will be fully transparent, as if that part did not exist. We do this just to give us an idea of what's going on inside the cylinder, instead of just imagining that. So from that point, we move on. Just a repeat creation. Here we see the profile that was used to create that part again is given, and then what we do is extrude to both sides, and once we extrude to both sides, we have that object. And then again, using a different opacity control just to give us a different look between the two, we have that. And then so from this point on, it's a matter of now doing a pattern. Create pattern would give us a replication of all these things we have done. Remember that as a result of create pattern, some joints will be transferred, some joints will not be transferred. The joints that are transferred are the joints that are entirely contained within the components. Those joints that are not contained within components, we will have to manually apply them after the pattern creation. So once we apply those joints after the pattern creation, we will now just go to we are now basically all these steps are, apart from pattern creation, all these steps are the application of as built joints, just exactly in the same way as we have done in the previous example. And then by the time we do that and capture the positions, and we are happy with the positions we have captured, rotating the individual cranks to the place where we want them, we just decided to make this V8 engine in the simplest kind of firing, by firing the V8 as if there are two sets of 4-cylinder engines, and using the 1342 firing order that we had for the single inline 4 engine. And at this point, we can just take a joint. We can just take a joint that is and let's do the animation again and see what's going on there. Animate model. Okay, by this time now, the entire model is animated, and we can just push this away and see the V8, and then just we can take several looks at it. We can look at it on the right, we can look at it from one front, we can look at it, we can take it, move it to the center so that we can look at it from the top and see how it looks like from the top. Okay, so, and that is the assembly of our V8 engine, just in the same way as we had the other engines in previous. A more compact arrangement of the V engine can be achieved by arranging the two cylinders and the crank in the way shown. Here is one unit of such an arrangement, and see it on the right.